Hello, I'm Philip Meyer. I'm working for Osmocom a bit less than a year now. I will show you how to use the osmo-sip-connector. Whoops. What is this? On my laptop I see the slide, but I don't know what happened. The laptop showed the slide, but the beamer not. Probably this digital stuff here on the display board. Yeah, anyway, the project is around for about a year now. And basically what it does is adds a SIP trunk interface to Osmo-NIP, and yeah, so respectively also to the in future to the Osmo BSC. The BSC MSC split is not fully done yet, but things are on the way. So by using the software, we can connect Osmo-NIP to a VoIP, voice over IP PBX. And yeah, it's not the case that it haven't been possible before. It was possible before using LCR software. That's the Linux core router. But the setup for that was a lot more complicated. I remember back in the days when I spent my first months getting all the OpenBSC that was with the BS11 back in the days. It took me months to get that running, but it took me even more time to get the LCR running. It was a really complicated thing. So I'm happy to introduce the osmo-sip-connector today, which makes things a lot easier. So again, the laptop shows the slide, but yeah. Okay, so there we have it. That's an overview of an average Osmo a network with Osmo components. That's basically how you would set it up. Of course, you have the BTS, and yeah, I have to mention this graph doesn't cover the old-fashioned E1 protocols. It's the talk also only focuses of an all-IP network. That's important to know because voice traffic would be handled different on an E1 line, of course. So the BTS is connected to Osmo-NIP, and then it would connect to some intermediate layer. Back in the days, that was the LCR, and that would connect to Asterisk, for example. That's only an example. It would work with any PBX software. Yeah, so we want to replace this huge LCR block, which offers a lot of features we don't really need. Of course, if you have already if you need ISDN features and if you have used it already, it's not a good option to replace it. But if you are only interested in having the VoIP support in Osmo-NIP, there's a lot of clutter we don't really need. I remember I had to configure call routes here and all that stuff that's no longer needed. So we just put basically a simple component there, which is the osmo-sip-connector. We'll have a closer look to this in the next slide. Yeah, in this slide I don't show how the voice traffic is routed. It's of course in an all-IP network that will be RTP. So let's have a yeah, good that it works. That is so let's have a closer look to how things work. Here I shown the BTS, of course, and then we have the Osmo-NIP and the osmo-sip-connector. They both are connected using mobile network call-controlled sort of protocol. It's in reality it's only primitives. The primitives are well defined. GSM 0407, but of course, how you implement the primitives is up to you. So that's a connection that happens over an Unix domain socket. So They both have to be on the same machine. But since this is a very lightweight component, it's no problem to do that. And then we have oh yeah, but there's one thing left important, which is important to mention: the call control. So the way how the call is handled is already implemented in Osmo-NITB. So we abandon the call control implemented here. We just turn it off and use the call control stack implemented there. And then the at the output, so to say, we have a real SIP trunk that carries all the signaling traffic, including the DTMF tone. And there's something special to have the DTMF tone handling. As you can see, the osmo-sip-connector is only connected inside the signaling traffic. It doesn't even see the RTP voice. So if you want to inject or handle DTMF tones, you would have to look and process them into the RTP stream. So it's not done here. It uses SIP info messages, which is standardized by some RFC from Kaplan. I don't know the exact number, but anyway. So that's important. The osmo-sip-connector has no ability to process any RTPs or to alter the voice traffic. Yeah, the SIP trunk has no authentication implemented, so when using it, there has to be a bit of care applied to security considerations. Of course, you don't have to put that on the internet somewhere. Yeah, and of course, everything is happening via IP, TCP/IP. So, yeah, the RTP voice stream, as I said, contains all the voice traffic here, and it's tapped directly at the BTS. Usually, an RTP stream is routed from the origin to the very end, or there may be RTP proxies in between. In this simple graph, it originates at the BTS and is then routed to the PBX or other end, whatever that is. Important to know here, there's no transcoding happened. I mean, there's no component here in that stream whatsoever, so no transcoding is happening. It's just the encoding as you would have it on the air interface as well. So that is a good thing and a bad thing at the same time. You get the undiluted RTP stream and can process them how you want. But also your PBX software has to support it, of course, or your called party. So maybe the PBX has to do some transcoding and has to support the codecs you use on the air interface. Yeah, and of course, it's UDP. You already know that for sure. So there we have it. So the osmo-sip-connector is basically acting as a translating entity between the MNCC protocol and between SIP. So when the call control is processed in here, at the same time it interacts with the SIP trunk, and basically translates the behavior on the classic GSM call control side to the SIP trunk VoIP side. Yeah, there's one thing left I wanted to point out. Yeah, some of you might already have some experience with OpenBTS. There it's done different. The OpenBTS software is more behaving like a VoIP phone. In this particular setup, we have a SIP trunk, so that that might lead to some confusion if you configure it wrongly at your PBX software. You have to configure a SIP-trunk interface at the PBX and route your numbers then. By the way, the authentication still stays as the NIT-B. So in terms of authentication, that still happens here. It's still the classic interface with the HLR and stuff. So let's have a look at the configuration. Even if it's very simple, we can go through that. So the first thing you have to do on the Osmo NIT-B side is to disable the internal call control and basically hand all things over to the osmo-sip-connector. And here I have a sample command line. You for sure you already know most of the stuff. Pass the config file, which I don't touch, by the way. So the config file of the Osmo NIT-B completely remains untouched. It's really just this command line switch here, the M. You can also use the smaller letter M, but that's deprecated. With the capital M, you have to apply pass to your Unix domain sockets. That's your interface between the osmo-sip-connector. So here that's a config file snippet for the osmo-sip-connector itself. So we are already there. So there's of course not much to configure. You just set up the pass to the Unix domain socket. And by the way, by picking different passes there, you could also have different instances in parallel. And the next thing is, apart from the Unix domain sockets, you just configure IP address at the port. Important here is, and that's very important, you normally have Osmo-sip-connector, Osmo NIT-B, and your PBX, which might be Asterisk or something else, on the same machine. And you might think, then I just put the localhost IP address. But that wouldn't work because these IP addresses are also used to negotiate the RTP traffic, and the BTS, of course, in most cases, most setups, it will be outside of your machine. I have setups where I can run the Osmo BTS software on my localhost as well, and then I can put the localhost there. But just to keep that in mind, you use the IP address of your machine that is also reachable from outside for the RTP stream. And you have a remote and a local IP address. In this case, they are the same. If your PBX were at some remote location, of course, you would have some different IP there. And then you simply start it. The -C, by the way, is I think that's common with all Osmo products, is always for the config file. It should have some standard name, which I don't know. I usually do it that way. And once you start it, by the way, it doesn't matter in which order you start it. You just start the osmo-sip-connector and the NIT-B. They will negotiate each other via the Unix domain socket, and will negotiate with the PBX software. And then you should be able to make calls just as normal. Then you have it, your network in the box with VoIP backhaul, so to say. There's a detailed information in the internet with a how-to, with sample configuration files you find there for downloading at our wiki. Excuse me, the path is a bit longer, but I'm sure the slides are handed out afterwards anyway. You also find it with Google when you Google for Osmo-sip-connectors, and you will immediately point it to the how-to, and that in detail explains with sample configuration files how to set it up. It's really not too difficult. And I was very happy that the burden of LCR was taken from me, and I have a simple component now to use. So that's it. Other questions? We need a mic.
My question is, when you use the Osmo-sip-connector and you pointed to something like asterisk, a few things. One, the registration is still maintained exclusive, registration of valid peers is still maintained exclusively by the NIT-B.
Yes.
Okay. And then the other question is, does it presents two asterisks not with any registration request, just with peers? It just is a peer interface.
basically just says, here's the call, do something with it, and then goes up into your dial plan, whatever, and the call gets connected. Yeah, there was, who was next?
Yes, on the slide you showed SIP over TCP. Is it SIP over TCP or SIP over UDP?
It's over TCP.
UDP or TCP?
Sorry, it's TCP IP.
But
it's
UDP?
No, the RTP stream is UDP. But SIP still remains... what?
It's UDP.
SIP is UDP? Oh, okay. Sorry. I confused the two.
Yeah. As per spec, it can be both, but I think we're using UDP only, like most people. Yeah.
Yeah.
Hello. Can you support SMS? So convert SIP symbol to SMS.
Oh, I must confess that I don't know if that will make it to through the osmo-sip-connector as well. I think not. I think that's still delivered with the NITB and with the mobile switching center in a classic way.
Yeah, indeed, we have already have an external interface for handling SMS, and that's SMPP. So there was no need to have yet another interface for SMS. So I mean, if you wanted to do SMS over SIP, I would recommend rather to go the route to either directly interface with SMPP or to then try to translate the SMPP into SIP again by an external component. But it is already exposed in some way. But okay, there was Keith next, and then Alexander over there.
Yeah, so I've done that. I have that working SIP simple to SMS gateway with free switch chat plan. But so my question was about the Osmo NITB RTP proxy mode with, I think, is capital P switch, that when you implement that, is that, how does that operating in this way with in relation to the RTP stream UDP directly from the BTS to your SIP, to your PBX? Because this is something that's still not quite clear to me. That's not operating then, so there isn't audio going through the NITB? Because,
I don't know exactly that. I didn't use this option before. Maybe Harald can say more. The expert.
Hi. No, it goes directly from the BTS to the PBX.
Okay, as I expected.
So what happens if you enable the RTP proxy?
It will be just ignored because the MNC interface is used to establish your RTP socket, and it's implemented in a way that it just forwards it to IP-based base stations. So if you ever want to add E1 base stations to use the osmo-sip-connector, we would probably then use the RTP proxy to map TROW to RTP first. But for the current use case, it should go directly from the BTS to the PBX. Yeah. One missing part of the simple osmo-sip-connector is the concept of handover. Or actually, it's left to the PBX to either discover changes in RTP source IP source identifier, or we need to have a re-invite, which is not implemented yet.
Yeah, so yeah, one more thing which is not yet implemented in osmo-sip-connector, just as a warning to the users, is that the hold call feature is not implemented yet because it also requires a SIP re-invite, which I think is also in to-do list, I hope. And one more correction to the slide previously, if you could go back to the screen viewer to the diagram with with LCR.
One sec. That's at the very beginning.
Yeah, and one more. Okay. Yeah. So basically, yes, here. So here you mentioned that it's connected to Asterix via CHAN LCR, which is the hard way to do that. And I'm not sure it's even supported, like it's been supported anymore, or things like this. And
The easier way is to do exactly as you do with osmo-sip-connector. Basically, you use LCR as a bridge between MNCC and a SIP trunk. And in this case, configuration is actually really simple. It's just a couple lines in the configuration, and I think it's published in the wiki. If not, we can publish it. It's just few lines of configuration. It's universal. It's not complicated. The most complicated part is compiling LCR, which is okay. Just from practical perspective. So because we are still using LCR because we need the call hold and some other features which LCR supports.
Hi. So you mentioned that there is no transcoding done. The audio stream is passed directly.
Yes.
Is there support for AMR and dynamically changing the codec depending on the channel condition, stuff like that?
Oh, I don't really know that. Probably it has to be supported by the other party because it's not osmo-sip-connector doesn't see the RTP stream anyway. So if there's some changes, it would be up to the other party to handle that.
Yeah. So basically, changes in AMR modes are done inside the RTP stream. And on the SIP side, you only enhance supported modes. So, and then it's up to RTP stream it's up to the headers in AMR packet to announce which mode is used for this specific packet. So you don't have to do anything on SIP side to enable this. That said, I don't think OsmoCom right now supports dynamic AMR change. I'm not sure. It does? Okay. Yeah.
So one reason to replace LCR was not only that like the classic ISDN interface is difficult, but we saw severe reliability issues in the field. That after a day it stopped working, connecting calls and other parts. And we also didn't want to do busy polling for the sockets, but be more efficient. So we wrote the simple utility, and of course for call holding or conference calls, patches are more than welcome. The other part for AMR, it's not supported in a way that you could make really good use of it. So it starts with the radio interface where you have your multi-rate configuration sent to the device with histories of when to switch codecs on the BTS itself. That's something we probably send but don't really configure correctly or don't implement correctly in the Osmo BTS. Also for the SIP part, yes, there is the initial mode, there is the mode set. But if you look at all other PBX with AMR, they're severely limited in what you could do with AMR and what actually works, or who actually looks at the SDP file. So we're probably in the same class of doing a sloppy job there, but it gets us far enough.
Okay, yeah, there's a question still. There was one more back there. Okay, because we, again, running out of time, so this will be the last question now. Sorry.
Oh, sorry.
So we switched over to using osmo-sip-connector, and we've been seeing that some phones can negotiate early media, but others can't. So we're wondering how that's supported, and we're wondering how you can implement early media support.
Yeah, maybe Holger can say more about this.
So in fact, we didn't support it until recently. I don't know if you have updated recently. Yeah. A few weeks could be okay. One of the issues is like when to connect the audio and when actually the BTS is receiving parts. So there was a behavior difference between Osmo BTS and classic Nano BTS of when it would receive data from a socket. So in theory, for the RTP handling, you can have like send only, receive only, or send and receive. And the way receive only was implemented in Osmo BTS didn't allow for audio to be received, but there's a workaround in osmo-sip-connector, and I plan to make it more proper in Osmo BTS.
Okay, but basically you don't know anything about phone specific because there was no. Okay, yeah, okay, yeah. Again, sorry. We have to move on to the next talk. Thank you for the talk, Philip.